Hello, and welcome back to Invitation to Puzzles, the series where we try to get you into a wide variety of logic puzzles. There's a whole lot of different types that you can play with, and we try and go through all of them here. Well, maybe not all of them. None of those like Hero Golf ones or whatever, but most of them. Let's have a look at today's puzzle. So today's puzzle features a few mechanics that we have seen before mixed together by FullDeck and missing a few cards. The few mechanics that we have here, we have arrows, where the digit in the circle is the sum of the digits along the arrow. We have black dots, where one of them needs to be double the other. And we have white dots that mark that the two digits on the white dot are consecutive. So we go, these are consecutive and these are consecutive. And this is a very striking looking grid, by the way. This is quite a grid to have, so we'll figure out exactly what to do with it. Reminder, as always, when I'm doing a FullDeck and missing a few cards puzzle, they have a lot of approachable Sudoku puzzles, and I know it can be challenging to find good approachable Sudoku puzzles. They have puzzles of a bunch of different levels on their website, which is linked below. You can sort by difficulty and that sort of thing, so if you want to find a variety of puzzles, you can do that. Alrighty, so there's a link to the puzzle in the description if you want to give it a try yourself. So I'm going to go ahead and try and give it a try myself. I see a couple things. So one thing I see that I'm not sure how useful it's going to be is the way that the 9... Maybe it will be useful. Okay. This 9 looks across the bottom of this box, meaning that one of these two is a 9. And I'm corner marking that. Remember, that just means one of these two cells is a 9. In particular, it means that digit is not a 9, which is interesting because circles on arrows tend to really want to be 9s. And now this black dot ratio is interesting because this digit is just the sum of these two black dot digits. And so what black dot digits combinations are there? Well, let me just write down all of them because there aren't actually that many. There's 1, 2, 2, 4, 4, 8, and 3, 6. That's literally all the ways that you can take one Sudoku digit and double it and get another Sudoku digit. Okay, well, this definitely isn't 3, 6 because those add to 9, and we've said this digit isn't a 9. This definitely isn't 4, 8, because those add to 12, and for other reasons, this digit definitely isn't a 12. I can also tell you it's not 1, 2, but that's going to require a slightly more careful consideration, namely a more careful consideration of what's happening in this column, namely the fact that there's a big arrow up here. And so if I make these 1, 2... the bare minimum I could make these 3 cells sum to would be 3, 4, 5, which is 12. That's too many. I hope that's clear. And ergo, I need to make these 2, 4. That's the only option that will work. Okay. Here's a different way of seeing the same thing, if you prefer. Namely, and this way works in far more generality, because this way doesn't involve me saying anything about anything other than, hey, we've got 5 cells of arrow in column 3. And so those yellow cells, they sum to, if you total them, they sum to the same thing as these 2 cells. And in a bunch of types of puzzles, you're going to see this sort of 5 equals 2 kind of arrangement. And basically the point is 2 cells want to sum to a small thing because there's only 2 of them. 5 cells want to sum to a big thing because there's 5 of them. Very profound, I know. But actually that puts quite a bit of tension because they have to be equal. So the bare minimum that these 2 cells, or these 5 cells can sum to is if they're 1, 2, 3, 4, 5. That is 15. Whereas the absolute maximum that these 2 cells can sum to is 8 plus 9. That is 17. And so when you have these 2 cells need to sum to 15, 16, or 17. Well, that tells me a lot. In particular, it tells me that neither of these circles can possibly be smaller than 6. because I need to actually make sure that their sum is at least 15 and one of them is at most 9, so the other needs to be at least 6 to pick up the slack. And actually, if you want, you can even say, well, that one's not 9, so that one's not 6, because if this were a 6 and an 8, that's not big enough. Okay. So that's a trick that works all the time in arrow puzzles. But I'm going to do better, because as I noted, these two cells only really have, therefore, one option, which is that they're 2, 4 adding to 6. Here's another trick that you might use, or you might remember and tuck away in your brain as a thing that you can use in Sudoku puzzles. Namely, that if you add both sides of a black dot, you always get a multiple of 3. And that's because if one of these is something, and the other is the one that's double it, well, what you can think of is you've got something, and then double it would be something plus something. And so if you have something plus something plus something, that's something, 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 that's a multiple of 3. Right? And so even if you erase everything from this grid except for this black dot in this circle, you would know the digit in this circle had to be a multiple of 3. Okay, and then as it happens, I've argued for you why that multiple of 3 can't be 3, and the setters have kindly told us it can't be 9 either. So this is a 6, and these are a 2, 4. Okay, so I went through all of those deductions in about 17 different ways. Take your pick as to which of those you want. Of course, you are under no obligation when solving a puzzle to do it every which way that I just argued. Now, you can think about this in a couple different ways, and it depends on which way you thought about this, which one you want. If you did it the sort of first way, where I just said, okay, what is this black dot, and realized the only thing it could possibly be is 2, 4, then you'd ask, okay, well, what's the minimum these can be now? And you'd say, the minimum these can be is 1, 3, 5. Those already add to 9, so this is a 9. Or perhaps what you remembered is that these two orange cells summed to at least 15, and therefore, once this one was a 6, this one had to be a 9. And you can convince yourself that probably it's not a coincidence that the math works out that those two are the same. Okay, but that's quite useful because now it lets me fill in the rest of this column is a 7 and an 8. Okay. Now, quite handily, if I take my 9 corner mark that I made at the very beginning plus that 9, it places 9 in box 1. Because remember, you can't put 9 part of the way along an arrow, especially part of the way along this arrow. If you put 9 part of the way along this arrow, it's going to sum to a minimum of 24, which is a lot too many, as they say. So the 9 is going to go there. And I'm going to know what these digits are because they have to be consecutive. And if you just check 1, 2, 3 is too small. 2, 3, 4 is the mama bear portion. It's just right. 3, 4, 5 is too big. So these have to be 2, 3, 4. If you liked my fun party fact about how black dots always sum to a multiple of 3, then you'll love this fact. Sums of 3 white dot digits like this are also a multiple of 3, and I'll leave it to you before I become too exciting to explain exactly why that's the case. But anyway, you could also have known if you had just this clue that this was going to end up being a multiple of 3. But until we knew more, it could have been 6 because these could be 1, 2, 3. Anyway, if I have these on the white dot, by the way, I know where on the white dot the 3 is, right? Because this is 2, 3, 4. So that's got to be a 3. I don't know what order it goes in, but I know that I've got my 2 and my 4 over there. Okay, and that lets me place the 3 along here. And that I see does something actually quite nice, which is that it rules 3 off of this black dot. Because that cell and that cell both can't be 3. And so now we really ought to think about what we can actually put on this black dot. Because, as noted before, there's only really 4 options. And one of them we even noted isn't even possible. 4, 8 is never going to be on this black dot unless I put a -5 here or something. And so this can only now be 1, 2, or 2, 4. So it's always from 1 to 4. And in fact, there's always a 2 in these cells. This is always, by the way, going to be a 6, 7, or 8. I had hoped... Yes, I can rule out... I can rule out 6 from this cell. So the most convenient way to rule out 6 from this cell, actually, and I think this is going to be quite useful, is to repeat our yellow-orange trick. So if you liked that before, good news, you get to see it again. If you didn't like it before, bad news, you get to see it again. So these yellow cells, there's 5 of them. They sum to at least 15, therefore. These orange cells have the same sum. They sum to at least 15, therefore. However, this 9 is not in one of the circles. And therefore, these 2 digits need to sum to at least 15 without using a 9. And so the only thing they can actually be is exactly a 7-8 pair. And what that means is that these digits, in fact, in yellow, need to be exactly 1, 2, 3, 4, 5. Because if they were not 1, 2, 3, 4, 5, the sum would be more than 15. And therefore, this digit is a random 6 that we have happened to find. I was really supposed to look at this black dot and not this one. It would have been way easier. We would have had to do way less of this. Anyway, moving on. Let's try to contemplate what happens now if, let's see, so this is a 7, then this is, of course, all 1, 2, 4, and that's 3, 5. I think this works out either way. Anyway, let's now look back at this black dot, because I think this black dot is way better. Namely, I think this black dot can literally only be 1, 2. It can't be 3, 6, because there's a 3 in the box. It can't be 4, 8, because that sums to too much. And it can't be 2, 4, because if it was 2, 4, then I'd have 3 cells in the box, chosen from 2 and 4. And that's too many cells in the box. So this is a 1, 2, which conveniently makes that a 4 and that a 2, and then sorts out at least a little bit of this. Sorry, that's not a 4. That's not a 2. In fact, there's definitely a 2 on this black dot, so neither of those are 2 either. And by the way, there's definitely... Yeah, I guess I might as well do this while I'm at it. I really should not, I think, have looked at this column at all. I think I was supposed to look directly at this, but I'm going to do this anyway. I can't put a 1 on this arrow at all, because if I put a 1 on this arrow, then it's going to sum to at most 6, and it can't. So this is from 3, 4, 5. And you'll notice that, therefore, there needs to be a 3 on this arrow if you want to really sort of beat this to the maximum, because... if I don't put a 3 on it, it's going to be 4, 5 summing to 9, and the circle can't be 9. So there's definitely a 3 up there, so there's no 3 up there. Okay. And one of these is a 1, but anyway, there's a little bit of flexibility. Okay. This arrow probably needs a 1 on it. I don't know if that's useful. I mean, I can even do it by Sudoku, I guess, because there's a 1 here and a 1 here, so there's going to be a 1 on this arrow by Sudoku. Actually, whether I want it to be or not, because I'm not putting a 1 in the circle of a 2-cell arrow. That's going to be problematic. You can put a 2 in the circle of a 2-cell arrow sometimes if you're into that sort of thing. Let's see. Okay, so what can the sum be? Well, it can't be 9. Well, let's see. What are the options? That's not what I want to do. So these cells can be from 1, 5, 6, 7, 8. Just naively. Not 6, because there's a 6 in the box. These can't be 1, 8, because then the sum would be 9, and that breaks, so there's no 8 over there. And they can't be 1, 5 either, because then the sum would be 6, and there's already a 6 there. So they'd better be 1, 7 summing to 8. And so we're in this sort of weird thing that sometimes happens with arrow puzzles, where something that looks like it ought not be restricted is actually incredibly restricted. At least it looks to me like it ought not be restricted. You can debate amongst yourselves whether you believe it should or shouldn't be. Okay, these are 5 and 6. Oh, and we even know the order because of the stray 6 over in that column that I probably shouldn't have. This is the other 7, 8. Oops, wrong marking. So we've got some 7, 8s looking across here. Okay. It's probably a good time to ask where 9 goes in row 6. Because again, you're not putting a 9 part of the way along an arrow. And so the only place 9 is possibly going is here. By the way, I keep saying that these 2 cell things can't be 3, 6. I guess it was true for this one. That one could have been 9, except for the thing. This one definitely still can't be 3, 6, because I would need to make this a 0. So this is still from the 1, 2, 4 flavor. Can't be 4, 8 either. So there's definitely a 2 involved. If this were a 2, 4, so I can actually work out, there's only 2 possibilities. If this were a 2, 4, it would go with a 3. And if this were a 1, 2, it would go with a 6. So funnily enough, this cell is always a 3 or a 6, which feels like something that might inform a black dot, but I don't think it is going to inform a black dot in this particular instance. I know what these digits are. If I am willing to write them out. We've got 1, 2, we still need a 3, we've got a 4, we still need a 5, we've got a 6 and a 7 and an 8, and we still need a 9. And that one's not a 9. Okay, and these digits we know an awful lot about, I think. Namely, this digit is at least a 4, which makes this sum at least a 7, so it's definitely a 7 or an 8. And so what's left in the box are 4 and 6. But this can't be a 6, because if this is a 6, then the sum would be 9, and this digit can't be 9. So in fact, that's a 4, and that's a 6. And now I have this beautiful opportunity to add 4, 1, and 2, and get that that's a 7. So that's a 7, that's an 8, that's a 7. 8 and 7, 8. Now that's a 1, 2. That goes with a 4 if I'm adding to 7. 3, 5 adding to 8. That all sounds good. Again, I think we probably did more over here than we, strictly speaking, needed to, but it was fun anyway, so I'm not going to complain. Okay, so got all of these. Okay, it's probably worth reminding myself that all of these have to be 6, 7, 8, or 9. And that one's not 6 or 9. And they have to be 6, 7, 8, or 9 because of the fact that they're length 3 and they all see each other. Okay. It's probably yeah, so there's a bunch of different ways I can argue this, and I'm debating how much you want to hear me say about this. This arrow can't be 7, because these would be 1, 2, 4, and that's 4 1, 2, 4s within box 9, so it has to be 8. The other way that you can do this, I think, is to note that actually you could sum these 5 have to sum to at least 15, plus that has to be at least a 1 for 16. Maybe that's actually okay. But it's definitely not okay if this is a 7. Because if this is a 7, again, you get too many 1, 2, 4s. So that's an 8. It's either 1, 3, 4 or 1, 2, 5 are the 2 options. I don't think I know a lot about it. I do know, though, let me argue that this is always a 1 or a 2, which I would do by sort of yellowing all of these digits, oranging these 2 digits, and then saying, well, the yellow, what does it sum to? Well, at bare minimum, it sums to 15 plus this digit, but it also sums to 17, I already know already. And so therefore this digit can only be a 1 or a 2 because we're adding to 15 and going to 17. So that is something. So that's actually a 1-2 pair in this box. I have a 1-2 pair in this row, I guess I never chose to appreciate. That's actually interesting. I was going to say I have a 1-2 and a 3 looking at this cell, but I actually even have a 1-2 3 triple in this row, or a 1-2 pair and a regular 3 if you prefer. Oh, and a 4. So this digit's big. This digit is at least a 5, and you can't put a digit larger than 6 on one of these arrows. And so one thing that you can internalize about 3-cell arrows that have no repeats, such as these, is they always have at least 2 of 1, 2, and 3 on them. If they don't have at least 2 of 1, 2, and 3 on them, then you could say, well, if you got a single 1 and then a 4, 5 would be the minimum, that's too many. So that's not a 1, 2, or a 3. So therefore, these both need to be 1, 2, 3s, and neither of them is a 3. So these, in fact, are a 1, 2 pair. You can get right away, which means that this is an 8 or a 9. You, by the way, could have totally done the yellow-orange thing with these 3 cells and then these and these, if you were into that sort of thing. I don't think it was necessary. So now these 2 are big, because they aren't 1 or 2. So these are a minimum 3 and 4. So this is now a maximum of 2. And this is certainly now an 8 or a 9. In fact, actually, if you look at it, 8 and 9 in this box just live up here as a pair. Oh, in fact, actually, if I look at it, the 6s actually look into box 5 and actually place a 6 here now, that I've done that little bit of work, and so I actually know that's a 9. If I am so inclined. I know that these are from, well, 3, 4, 5, right? There's no 6 left in the box. And one of these is definitely a 3. I don't know how useful that is. Okay, instead of dwelling on that, let me just place that this is a 7 first. Because the 7 in this box has to go somewhere, and it's not going anywhere but there. And so, naively, this is a 3, 4, or a 5, but this can't be a 3, because if it was, I would need to make these 4, 5, plus something is equal to 8 or a 9. So, in fact, this is a 4 or a 5. I'm adding to 7. That goes with a 2 or a 3. I'm trying to see if I can desperately form like a 1, 2, 3, 4, 5 sextuple or something down here, but I don't think that I can. I guess I can place the 9 in this row now, because I'm not putting a 9 part of the way along an arrow, and I'm not putting a 9 in a column with another 9. So we can at least place that 9, and we can do the same with the 8. Because I'm not putting an 8 on an arrow that adds to 8 in a column with an 8. That's doubly problematic, so I'm certainly putting the 8 there. And we could just keep going. Where's the 7 in this row? It can't go there, because that would make this arrow add to way too much, so it can only go there. So let's see, that is not a 1. It is a 2 or a 4. Okay, and so now one of these 2 is... Okay, well, let's just ask it this way. Where's the 6 in row 7 now? And it can't go there, because that would make this a minimum of 6 plus 1, 2 is 9. So the 6 goes there, which now, to add to 9, means I need a 2 and a 1. And so now this is not 1, 2, 5. This is 1, 3, 4. And I actually am going to know the order if I do the Sudoku. So Yeah. I was going to say 1, 2, 5. No, it's 1, 3, 4. Right. It's 1, 3, 4. That's got to be the 1. These are a 3 and a 4 in that order. Okay. And I notice the Sudoku is escalating rather rapidly as we do this. So these have become a 4 or 5 pair. That has become a 3. This seems to have become a 2 and a 1 and a 5 and a 1. Sudokuing intensifies. This is 7, just because it's the only digit left in the books. Let's see. These are a minimum of 3 and 5, which is 8. I was going to say a minimum of 3 and 4, but I caught myself because actually these digits see 1, 2, and 4. So 3 and 5 is the minimum, and it's also the maximum. Oops. So if I hit the right key, that's 3 and 5 make 8. Let's see. This pair is a 7 and a something and a 5. These are 5 and 7, so they go in that order, and that digit is the last in its row, column, and box. So take your pick as to how you resolve that this is a 4. But I recommend hitting the right key instead of the... Well, I did hit the right key. I just also hit a random additional key. Don't do that. It makes the puzzle go worse. I do these things so you don't have to. These are 2, 6, and 9. So that's the 2, that's the 6, and that's the 9. Looking across the row, I seem to have a 1 that needs to go there, and a 4 that seems to go there, which has made that a 5 and that a 4. Oh. Zeta. This has been available, by the way. As soon as I filled in that this was a 3, I could have filled in this arrow. It would have all worked out. It would have been fine. But anyway, I just didn't notice. That is a problem, a frequent leak I have with these. But I will notice this time that 3 plus 5 plus 1 is 9. So that's a 9 and an 8. Let's see. These are, one of them is a 2, and I somehow don't know which one. And the other is a 7, and I do somehow know which one. Let's see. What about these? One of them is a 5, one of them is a 6, and one of them is an 8. That one's the 5, that's the 6, and that's the 8. Let's do this row now. These are 6, 7, and 9. That's the 7, that's the 6, that's the 9. And then we've got down here a 2, 4, and 5. That's the 5, that's the 2, and that's the 4. Really enjoyed that one. That one was very nice. And a great opportunity to talk about some of the arrow tricks that show up. You probably could have gotten by without a lot of the arrow tricks, but again, I try and sort of throw in some of the things you might think about if you're doing this. But I really enjoyed especially the sudden moment where we're able to place 9, then 8, then 7, then 6, then 5 into this row all at once because of the work that we had done. Very beautiful puzzle. I enjoyed that one a lot. But that is going to be all for today's episode. Leave a comment and let me know if you learned something or if something made sense, or if you have questions about anything, if there's any sort of genres of Sudoku you'd like me to cover, or any genres of other puzzles that you'd like me to cover more. I'd be more than happy to do a video for you. But that's all for today's episode. Thanks for watching. Bye for now.